Hi, my name is Judy Janowitz. I'm the Confocal Core Director at the Magee-Womens Research Institute, and I'm here to tell you today about the new Stellaris Confocal that we got off of our S10 grant. This is going to be a beginning to your training on the confocal system, and we hope that you enjoy and look forward to training you in person after you've seen the videos.
Thanks everyone for joining today. We're going to be talking about the Leica Stellaris 5 that's new here at Magee-Womens Research Institute. It's a totally new confocal platform designed to help users dig deeper and discover hidden data in their images. And so we're going to be talking about the technology that goes into that, but then also just everyday use. So. In terms of everyday use, first things first, we got to turn the system on. Pretty easy in this regard. We don't have a lot of boxes to turn on, just a couple of switches. So down here to the right of the microscope in the system is the laser supply unit. So this is where we're going to turn everything on. It's a global switch, so we'll see the microscope kick on. We have a chiller over there that's going to kick on. We have our environmental control that's going to turn on as well. So everything comes on with that one switch. The next switch is the laser switch. There's actually several laser safety mechanisms within the system. So this is the first of several. The next laser safety mechanism is this key. So the key is a little less important. The key can stay in a vertical position and it's just controlled with the switch. But if you walk in and notice that the key is in a horizontal position, turn it vertical. You're good to go. There's an emission light there. It's a kind of a white glowing light on the front. If you don't see that, then your key is not in the vertical position. The next thing that you would do is turn on the computer and let that, load up and get going. And then you can load the software. But we're going to hold off on talking about the software first. We're going to spend some time reviewing the components on the microscope.
Okay, so a couple of things to notice when you come into the room. This table is actually an air table, and so we don't want to be leaning on the table and such like that, just like on the other confocals that we've used previously. You should also notice that there is equipment on the side. All of this is taken care of by the core itself, so please do not touch anything besides the microscope body itself and the computer and the on-off switches unless otherwise instructed. You should also notice that the area is generally clean and that the only things you will find here are objective oil and water and pipettes for the 40x objective. You should not take these out of the room. If you need additional oil, you should also contact the members of the Janowitz lab to replace them. So you will note that the immersion oil is kept in a little tray which has a paper towel so that if oil drips down, just like this one, it accumulates into this rather than onto the air table. The other thing that's really important, and I know this seems trivial, is that this actually needs to be tightened when you are done using it after every use to make sure that if it accidentally falls over, it doesn't spill over all of this new and beautiful equipment. So when you first come into the room, the thing you're first going to be interested in doing is putting your slide onto the microscope itself. But it's really important before you do that that you make sure that the person before you actually took proper care of the microscope itself. So we need to bring up this head so that we can get access to the slide holder and to the objectives themselves. This microscope has a 5x, 10x dry, meaning we don't put immersion oil or water onto them. We have a 20x multi-immersion objective, a 40x water objective, critically water only, and a 63x oil. So your responsibility when you first come in is to actually move between those objectives and make sure that there's no immersion oils on any of the that they've been properly cleaned prior to you actually starting. Because if I come in afterwards and find out that the 40x is dirty, but you only use the 63x, I'm still blaming you because I'm not tracking down who actually used the equipment. As the user, you are responsible for the microscope and its proper cleaning. If you come in and it is dirty, you need to report that to the Yanowitz lab so that we can talk to the previous user and make sure they've used it properly. So to go from objective to objective, this is actually all automated. You may not change the objectives by hand. The 40x objective is very fragile, and if you turn the objectives by hand, you are at risk of damaging the 40x objective. So we move all of the objectives from this front panel, and there's a little icon that looks like an objective itself. And you can see that this has a 5, 10, 20, 40, and 63x numbers, just corresponding. And you simply press and double press on those numbers to move each of the objectives. And so what I'm doing here is actually looking at each of the objectives and making sure they're clean. This is now the 20x objective. I'm going to the 40x, looks clean, and the 63. And this one looks clean as well. Okay, so now I would be ready to put my slide on. So I have my slide that I brought in. This is an inverted microscope platform as our previous confocal. In this case, we're going to start by just putting it on the 5x objective, and we'll come back and add oil later. Lots of people like to put this position of the slide holder in the middle, or you can put it all the way to one side. I tend to like it to one side because I can then just move one in and out, and when I'm adding oil, it makes it easier for me to just keep the slide in one position to the side. So I'm going to put it on the 5x objective. So I'm going to take my slide. It's really important that you make sure that your slide is upside down. Because it's an inverted scope, the cover slip goes down. And you can see that I basically, because I've set this up so that this far right-hand holder can't move, I start by putting the slide all the way in on one side, and then slowly bringing the left side in and dropping it down into there and then tightening it up. And now it's in position to start imaging.
Great, so we have the slide on, the objective lens selected. So the next step, I guess, is to center the slide if it's not already centered. So we're going to use this device right here. This is called the Smart Move, and this allows you to control the XY stage with these two knobs right here. This will move the slide in the Y direction, and this will move the slide in the X direction. And then the knob on the back is your focus, and we'll get to that in a minute. But my workflow is to put the slide on, just like you saw Judy do, and then look at the slide so that the objective lens is centered on the cover slip to give us the best chance of finding the sample that we're looking for. So now I'm ready to, I guess, tilt this into position. This needs to be in position in order for the lasers to fire. It's a laser safety mechanism. So if you have that tilted back, lasers won't come on when we're ready for that. So make sure that that's down. Okay, when the microscope turns on for the first time, there's an initialization where the focus drive will drop to the bottom of the travel range. And so the bottom of the travel range is very much out of focus. So we have programmed in a focus position to help users. This button right here, if you push and hold, it will take you to, oh, there we go. Sorry, my hand blocked it, but it will take you to the focus position. This one down here will lower the objective lens. This one will focus it. And it won't be perfect, but it'll be close and get you to within the range where you can find your sample. Now we are in the contrast menu, and within this menu, we can activate things like bright field for transmitted light, DIC for contrast and transmitted light, as well as fluorescence. Currently, with the red icon, we are in confocal scanning mode, that's CS mode. So in order to look through the eyepieces and find focus, you'll need to push the fluo button, and you can hear the microscope switching over. And then when you are ready to look through the eyepieces and find focus, you open the shutter, choose your fluorescence filter cube down here. Once you've found focus, obviously we're going to keep that shutter closed so that we're not photo bleaching. But then once you've found focus, we're going to switch back to confocal scanning mode so that we're ready to activate the confocal and I guess start acquiring images.
So now that you have your slide on, you want to find your sample. So we're going to be doing that by a combination of moving the slide around with the X and Y controllers to the right and using the focus knob here on the microscope itself to come into focus. So I'm peering through the eye piece. I use this, my sample has DAPI, so it has 405 fluorescence. So I had already turned on the 405 LED. I'm looking through and moving the stage around. And now I found a worm and I'm bringing it into focus. Okay. And now we switch. And then I turn off the shutter. Okay, so when you come into the room and turn on the screen, you can see that it has a screensaver on it. We have multiple different users. Most of you will be using the LASX user. You can see that there's one for the admin. You do not have the password for that. And you will be able to, you won't be able to access the one specifically for my lab. Upon training, you will get the password for the LASX user. I'm going to type that in right now. And you can see that that logs you in. Normally this screen will be blank, but you will see that there is currently a window because we are recording. Conveniently, on all of the pieces, all of the lens paper, we will have the password written at the bottom in case you forget, so that there's a reminder in the room as to the password, just in case someone in my lab isn't around and you forgot it. Okay. Also, I'm going to move this here. You will note that there's a large X and there is a single piece of software right in the middle. This is the software that you should be using on this computer. This is the only software you may be using on this computer. You may not use any streaming. It's not connected to the internet, but you may not use it for any other purposes except for the use of the LASX software. If we find that you have added additional software or used other software on this computer, you lose your privileges to access the confocal microscope. You turn on the software as usual by double-clicking.
It's actually a two-stage load, so it's going to initialize some functions immediately. If you arrive at the microscope and you notice that there are some blank screens right here and you can't click OK, you would just select this setting that's called machine, and then that will activate everything on the screen, and now you can click OK. And so from here, the software will initialize. It's going to start communication with the hardware, and you'll hear some clicks and adjustments and initializations on the hardware, and it will load. Okay, it's going to ask to initialize, and so this is definitely click yes on this. If you do not click yes, you will not have function of the motorized stage in the software.
So usually when you first come into the room and you turn on the confocal machinery itself, you would also activate the software immediately. So that way, when you put your slide on, the stage is already initialized and in focus. Because we didn't do this in that order, we're going to go back and actually confirm identify a new item on our slide using the microscope. Okay, we want to change to the 63x objective for the particular sample that I have. We need to look at it on high power. And because I've conveniently put the slide holder all the way to one side, it becomes very easy to maintain the position of the object I have found simply by just moving the left-hand slide holder and taking my slide out. At that point, I will switch to the 63x objective. You can see that it drops the objective and then brings it back up to the position that I'm in. You will then need to manually bring it down to the down position so that when you put the slide back on, you can bring the objective back up to the appropriate position rather than crunching it down onto the objective itself. So Mike's going to show us how to put oil onto the objective properly. So on inverted scopes, we put the oil onto the objective rather than onto the slide itself. And this is really important to make sure that you get the right amount of oil and not too much dripping down the sides of the objective.
We are going to use type F immersion oil. This is very important to use. Do not mix oils between the various microscopes in the facility. This is the oil that should be used. If you have any questions, there's a nice little Leica label on there, so you are good to go.
All of the immersion oil is maintained by the confocal core. You should not be bringing your own oil. It will be here, as we discussed prior, adjacent to the microscope itself.
When you apply oil, you have this like dipstick dropper, and you can see how the oil beads up at the bottom and drips. When you have a lot of oil in the bottle, it's a good idea to scrape the sides of that so that you have just a single drop on the bottom and it stays put. It's not going anywhere. That's how you know you have enough and not too much. And so once you have done that, you just touch the oil to the surface of the lens, get a small amount of oil on there. You can see the oil is already spreading, so it's kind of important to move quickly to get your slide on. And in this case, I'm going to use my touch screen to return to the focus position. I can see that I've made probably really good contact with the oil. There's an oil ring that you can see. It's a meniscus. That's a very safe amount of oil. Less is okay. I would not put on more oil than that. If you notice that you put on more oil than that, then remove your slide and clean it.
You will note that when Mike put oil onto the objective, that he brought the oil itself very close to the objective itself, rather than keeping it on one or the other side. This is important because you do not want oil dripping onto the stage itself, or worse, into the holder of where the objectives are. So this is really important, that you're simply opening it up, making sure that you have the right amount, and then bringing it down to the objective in with the oil very close, the bottle really close to the objectives themselves. Mike's going to tell you a tiny bit more about the stage insert because this is actually really fragile.
Yeah, so this stage insert that you have right here, you'll notice that it's kind of wider than the XY stage. It's resting right on top. There's actually a motor inside of here, and it's a galvo motor. And the galvo motor is very fast, very precise, but also incredibly sensitive. So when you are loading your slide, whether it's for the first time or adding oil, changing slides, whatever it happens to be, sliding these sliders back and forth, be careful not to push down on this insert. Once or twice won't kill it, but over time it will cause damage. It'll push it out of plane and just make it harder to use. So be sure that you're careful with it, and again, only applying as much force onto the slide as is required to hold the slide in a position. So be nice, gentle. All right, so we're going to go ahead and move this back into position. I'm more or less in focus. I'm going to use the touch screen now to just confirm that when we move from 10x to 63 that it's in focus. And most likely it's not, but I'm probably pretty close. So now I'm just using the focus knobs on the microscope to get it into focus. This can be challenging at times, and so I use the same Z screen on the microscope as a reference point. Right now I'm 7 microns above focus. This can be tricky at times, so.
Can I find my sample?
Closer.
So if you're having trouble finding your sample, you can go back to the 5 or 10x objective, even though there's oil on the slide itself. because you made sure not to put too much oil to drip onto those objectives. And there's a large working distance between the 5 and the 10 and the slide itself. So that's what I've done. I've gone back to 5 to find my sample, make sure it's centered. And now I'm going to go back to the 63x and do the fine focus that's needed. Yep, there we go. And now my sample is perfectly centered. And I'm going to turn off the illumination and turn it on to the confocal.
Now that we have the sample in focus, we're ready to go. We can really dive into the software here. So when you first launch the software, this is what you're going to see. It's a blank, this is more or less the blank software. For the purposes of today's demonstration or instruction, I'm going to increase the size of the screen with this little slider. First, I want to point out that we are in the Acquire tab. I know that I'm in the Acquire tab because there is, it's highlighted in red. There are other tabs up here which, are not going to be used as frequently, but we will get into them a little bit. Process and quantify even less, but certainly in process. So for now, we're in Acquire. We're in Acquire data. As I look over here, I have 2 tabs. One is for your saved data, which is called, Leica calls them projects, but by default we're in the acquisition tab, again for acquiring images. So down inside of the acquisition tab, I have controls over the scanner. I can control Z-stacks, time lapse, things of that nature, and then up here, as I move over into the software, this is where I have control over things like the objective lenses. There are some other controls in here which we're probably not going to spend a lot of time on, but most of it is going to be right here, which is where the image setup is. And so when we, want to image Alexa 488 or a DAPI or whatever it happens to be, we're going to do all of that setup right here. And Leica calls this image compass. There are lots of directional names to this in the software, and so we'll see that and make some jokes about it. But if you hear me refer to image compass, I'm referring to this right here. Our live images are going to be displayed on the screen over here, and we have a few different visualization, buttons that we can use to see our data. Whether it's in 2D, which is right here, or there's a 3D button over here, and I'll get into that as well. Okay. In order to get started and get an image on the screen, we are going to activate our lasers in the software. So we've already turned them on with the hardware, but we need to get those lasers communicating with the software. And so that's done with with this icon right here. It's a dot with 3 lines.
This confocal has 2 different types of lasers. It has the DAPI 405 laser, and then has something called the WLL, or white light laser. So that's this broad spectrum laser that basically will illuminate from 485 out to the ultraviolet, basically. So we can collect fluorescent images in that wide range with lots of different fluorophores that all of us are using with our antibody staining. But it's a single laser as opposed to the older confocals, which have different lasers for different wavelengths.
That's right. So it's there's a 200 nanometer range. Within that 200 nanometers, we can choose any laser line we want. 489, 532, 541, whatever you want, because the laser will adjust to that that setting that you've selected, or what I'm about to show you is how the software just handles it for you. You don't have to worry about it. So I turn these lasers on. The 405 is on. The white light laser is on. If you forget to turn those on, no big. The software will just toss up an error message and say, hey, do you want to activate the lasers? Yes. And then you'll be off and running. So,
so if you're using only DAPI, which occasionally, for example, my lab does to just look at chromosomes during meiosis, you would only turn on the 405 laser. If you don't need the DAPI laser, you only turn on the white light laser. There's no obligation to turn on both lasers to use the software, but just the ones that you need.
That's a great point. Okay, so the image compass is set up to, I guess, incorporate some modern usability, search, drag and drop. These are functions that we're all used to and using whatever computer you use, and now they're active in scientific software. So
How did you change this?
previously, someone had typed in Alexa, Alexa, give me 488. So Alexa 488 is a very common label, and so I've searched for Alexa 488, there it is.
But how did you have all of them?
When you delete anything in here, the entire
Oh, I
list
see.
is available to you.
Ah.
But this is where the search function comes in to be helpful because, you know, finding your label can be a pain.
I see.
And
So
so
somebody typed
searching
in
for it
Alexa.
makes life easier.
Ah. So this would also happen something like, what are some of the other dies? Hookst. Does it have Hookst?
It sure does. I'm not very good at spelling hooks, so
H-O-E? H-O-E.
I'm not sure why the search function stopped working. Hang on. Just,
No? It didn't stop working?
Yeah. Oh, there it is. Look at that.
Hookst. Great.
34,580. So I'm sure that's close enough. If there's a label that's not in the database, no problem. As long as we can download it online, we can import it into the software.
That's awesome.
Or if it's not in the software, we can actually create our own, custom.
So Mike, I noticed when you changed that it changed what's happening over here. So hover. So if you're on a particular thing, what is this showing us now?
Yeah. So that is your emission curve. So if Hookst is something you use a lot of, real quick, I'm going to click, I'm going to drag, I'm going to assign it to my favorites bar. So now I have it handy all the time. And now I can either drag this here, put it into position, I'm ready to go. This, what it's showing me is the emission for Hookst. And you can see that this will bleed into basically every
Right.
label you have.
Right. So basically, what you're saying is, if you had a slide and you'd stained like we have with something that would illuminate in the 488, I can't be collecting the Hookst at the same time as the 488 because there's still going to be quite a bit of signal there.
That's right. Yeah, and the software will show you that there's overlap.
Right.
There's a little icon for that. But all right, so if we type in 488, we can find our Alexa 488, and as I hover over, you can see that, yeah, look, 488 and Hookst overlap. It's just the way it is. But I'm going to put it in there. And so right now I'm doing a simultaneous scan without getting too much into it. Basically, both lasers are going to be firing at one time and collecting light at the same time. So it's simultaneous. It's all happening at once. But since Hookst and 488 overlap, we want to try to eliminate that overlap. One way to do that is based on time. So we can do sequential. So we can do Hookst and then 488. And the way that we do that is by adding a new setting, grabbing this 488, dragging it into the next setting, and now I have only one laser firing at a time. So it'll go 405, then 488, 405, 488.
Okay, so what you're telling me is that basically each of these individual windows is actually a reflection of the lasers sequentially.
That's correct.
Okay,
Yep.
so when might I actually use two different fluorophores at the same time?
If you want to go very fast, because when you switch back and forth, that takes time. Not a lot of time, it happens
Right.
within milliseconds, but it does add up.
And when you're scanning and it's switching between these, is it doing it at every position or every line, or is that doing screen by screen?
Great question. So right now it is doing it line by line, and this will become clear on a confocal microscope. If you're not familiar with confocal, it actually will scan, like a printer. It'll, dot by dot, line by line, and so you can actually see it building. And so we can switch the laser line by line. So red, green, step, red, green, step, red, green, step, red, green, step, that sort of thing. Or we can do in this case, all blue, all green. When we do red, green step, red, green step, red, green step, that's called line sequential. When we do all red, all green, that's called frame sequential. So we change this on this little button right here. This
it says line.
Yeah, where it says line. There's an icon with a bunch of lines on it. That sounds good. And then there's this other one called frame. So if we wanted to do, in this case, I'm sorry, all blue and then all green, we would choose frame. If we were doing a Z stack, we might choose to do
all the blue and
then all green.
Okay, so I can understand sort of some of why somebody might want to do that for a stack. What's the advantage of frame versus line? Because it seems like frame is going to be faster.
It's actually the other way around. Line is quite a bit faster.
Oh, really?
Yeah, line is faster.
Huh.
And so if you, now it depends on, there are some caveats to that, but 9 times out of 10, line is faster.
Oh, okay. So most of the time, I noticed it defaulted to the line.
That's right.
So most of us really just want to keep it on the line scanner.
That's right. Yep.
Okay.
Okay.
And for this, so I don't know if I told you, so for the slide that I put on, we have DAPI, Alexa 488, and Alexa 568. So maybe Michelle could try putting on the other window so that we can make sure we know how to do it.
Sure. Yeah, of course.
Okay, Michelle, you're up.
All right, Michelle.
Do you remember how to? Well, you have to search and you want to find another, right? We don't want to do it at the same time as these, so we want to actually, once you sit down.
Yeah, grab a seat. We're actually looking for the 568. Yep. We've already got 488 in there. Look at that, found it. All right, almost. You're not quite there yet. We need to first add. Well, you could drag it in.
No.
Yeah. Go ahead.
Yeah, that's right.
Mm-hmm.
Yep. So look, another window came up. Yeah.
Click and drag. That's right.
Great.
You did it perfectly. I don't know if you saw it, but when you drag this in, you put it in the void. Notice these other icons that show up, Heidi S1, 2, 3, 4. In a more advanced scenario, you could potentially assign a label to a specific detector. But we don't need to do that. We're just going to let the software do its thing. Okay. And you also probably did not notice, which is by design, that when you dragged in the 561, this 488 channel actually changed.
Yep.
The software is going to adapt to your settings and optimize the system for whatever you've selected. So in this case, the 568 peak absorption is actually 579. So and 488 peak absorption is actually 499. And so the laser is going to tune to peak absorption so that you get maximum yield in fluorescence. And this is one of the powerful features of the white light laser. And if you're not sure where maximum absorption is, or peak absorption, whatever you want to call it, there is this icon right here that says show excitation. And now you get a new curve that shows your excitation curve. Cool. And if you were feeling saucy, you could change the laser position by clicking and dragging.
But why would we want to do that? Isn't it already perfectly set?
It is for this scenario.
Ah, okay.
There are scenarios where maybe you do need to manually adjust it. It's a little more advanced. I just want to point out that it's possible. All right. So, like I said, the software took care of a lot of things for you. It turned on a laser, turned on a detection window, took care of all that stuff. At this point, we can see if there's an image on the screen.
So wait, I'm confused about one thing. You pointed out to Michelle these different detectors. Could you tell us about the detectors?
Yes. Well, so the on a Solaris 5, we have all new detector technology that is incredibly low noise and very high sensitivity. For about 10 years, Leica's been making what's called hybrid detectors, which takes kind of the traditional confocal detector and puts a new twist on it with some new technology. And so now this new version of hybrid detectors is totally different. Old confocal detectors, or I'd say previous generation confocal detectors, use vacuum tubes, right? Photomultiplier tubes. These are solid state silicone detectors, and
So is that what's in this box back
the
here?
detectors are actually directly mounted to the scan head.
Ah, so it's in this part.
That's right. Yeah, it's totally different than the Nikon design. And actually, if we take a step back and look at the poster, I want to shrink this. Here we go. This is actually the scan head. So we're talking about lasers, we're talking about emission, we're talking about detectors. And this is actually the scan head that is mounted onto the microscope itself. So it's a perfect representation of that. With our laser being here, white light laser, there's some technology around how we deal with the white light laser, which is between these two prisms. But then once you excite your label with the white light laser, it will reach inside of the scan head this prism. The prism will then split that emission light into its components, like a rainbow. You can see that rainbow there. And then that rainbow is projected into the scanner and onto the detectors. And so the detectors are positioned in this W format so that we can be fully spectral with our detection. Position 3 is right in the center. From position 3, we have position 2 and position 4, position 1 and position 5.
So does it matter? We loaded those as 1, 2, 3. Does it matter the order of the detectors that we're using?
To some degree, yeah. Detector 1, I mean, these are colored, blue, cyan, green, for a reason, because your DAPI is pretty much, or your blue is pretty much always going to be on detector 1.
Right.
And your far red is pretty much always going to be on detector 4 or 5.
Okay.
So it does matter, and that's kind of why, letting the software do the thinking for you is helpful. There are some scenarios where you need to be smarter than the software and assign specifically to the detector, but
that's in the advanced user training.
that is when Genevieve comes out here and really works with people hands-on.
Perfect.
Okay. All right. So at any rate, yeah, this is the scan head, and I might refer back to this later on, because all of these functions are projected, I guess, or displayed in the software, because these little adjustments right here that I'm making, with this being high DS1, this being high DS2, this being high DS3.
I see, because it's highlighted.
Yep. You can now start to think about like how that's actually, I guess, what's actually happening inside of the scan head.
So is there a reason that I would want to change? I mean, so you were changing this, but so I have two questions. One is, why would I want to change it if the machine is so smart and it's already preloaded? And the second, because it seems like it would be just better to load them all and just go.
Yeah.
Right? And then the other thing is, okay, so now you've done that, or what if I accidentally do that because I don't really remember what it was that I was supposed to be doing? How do I X out and start over?
Good question. Okay, that's actually a perfect lead-in. First question, before you make any changes, see what it looks like on the screen.
Okay.
Right? If you start to have problems, if you start to see like bleed through, or you're seeing signal that you shouldn't be seeing, that's when you go in and you start making adjustments and changes. And there's all sorts of tools within the software to deal with things like bleed through and autofluorescence and some of the challenges that you guys face on an everyday basis. If you do start to make changes and things go haywire, there is a way to, I guess, get back to it, all right? One of them is to close out and create it anew, or you can open up this other menu called Die Assistant.
Okay.
Die Assistant is really helpful for new users. It's a duplication of what's happening inside of Image Compass, but it gives you a menu. So where I knew to create 3 settings and then drag them in, some users aren't that advanced and they need more help. And so Die Assistant offers new users that help. So you can click this Die Assistant, and then quickly see a menu of image setup parameters. Non-sequential is a German way of saying simultaneous. And you can see that the challenges with simultaneous, because there's a heavy amount of crosstalk that's happening.
Yeah.
Or crosstalk, bleed through, whatever you want to call it. Line sequential with 2 sequences. This is quite a bit faster, but you can see that, sure enough, there is some crosstalk with the host.
Yeah.
And then there's this frame or stack sequential. We've talked about frame and stack sequential. This is slower, but and then this is what we were using previously, which is line sequential, 3 sequences. And look at that, no crosstalk.
So if you want that line, can you just select that and have it be put here?
Yeah, you just go ahead and click apply.
Okay.
Boop, done.
Okay, so before we start, we didn't actually use hooks, we used DAPI.
Oh, wah, wah. Okay.
But I wanted to know if it had hooks.
Okay, it does. So if we want to change it, we can click these 3 lines right here.
Okay.
And just type in DAPI.
Ah, much better.
And then now we can click apply.
Okay.
And I don't think it's going to change the detection
No,
much.
nope.
It gets recorded in the metadata differently, that sort of thing.
Well, it's important for us.
Yeah.
Okay.
So anyway, once I have this set up, I'm ready to go. I don't have to make any changes. I can just see if there's something on the screen.
Do you have any questions about the setup? Maybe we should try. Can we try the dye detector thing and make sure, like if we were coming in with something else, just to make sure we understand how to use it? I know for now. No, I just want to use it.
Okay, sure.
Yeah, I think it's just important. So if we're going to use the dye
Oh,
detector.
dye assistant. Yeah.
Dye assistant.
I
right?
thought you meant you wanted to create your own custom label. I was like, that
No.
is advanced training number
Oh,
3.
so here you're saying like if I was adding a 4th. Oh shoot, where's? Uh-oh.
That's okay.
I get rid of it that way?
And you said the software wasn't intuitive. See, look at that. Come on.
So what's this S?
The Heidi S is our standard hybrid detector.
So
Yep.
does it matter which is which?
They are all the same on this system. So
Okay.
you don't have to worry about whether or not you have the signal on the right detector.
Oh, and here's the search. So now if this one had, oh, I see Alexa 633. So maybe we would be doing a 4 color.
Bingo.
Yep.
Yeah.
Okay. Oh, and then I would go down. I see. So I can do them all separate, but maybe here
So if you're doing
I might save time. Oh.
bingo, you might save time by doing
By
something
doing
like this.
this one.
Right. Yeah, exactly.
Oh, okay.
Yeah, it takes a minute. There we go.
It's good to know not to be too impatient.
Yeah.
Okay, and so if I were here though, and I wanted to get rid of this, is there like if I was like, oh, actually the
Ooh, I don't want that. Yeah.
yeah,
you can,
or
you can
like
either,
particularly if the like let's say we do image and that's crappy, so we just don't want to image that. Can we take it away from here without going back to the dye assistant?
Yes, because if you go back to the dye assistant, it will reset all the other things.
Right.
So if you've made changes. So in this case, what we're going to do is we're going to select this Heidi S4, and I am going to turn off Heidi S4. And then I'm going to select this laser line and click the trash can.
Awesome.
No
Okay.
recycling here, straight into the garbage.
Okay, good, perfect. Got it?
I've really held off on my dumb jokes, and
I know, I appreciate that.
It's going to start happening. I can't help it.
Okay, so since you talked about favorites, so what you're saying to me is rather than us preloading in a bunch of programs which have 1, 2, 3, 4, 5 colors, really this dye assistant has done that for us.
Yeah, absolutely.
So when we want to just come, we're not going to. So previously on other scopes, or even on our other Leica, our Thunder system, we have sort of this little drop down which has a bunch of different settings. Instead, what you're saying is we need to go to this dye assistant because that's really our best friend.
Yeah, in my opinion, that's going to give your users the most success.
Okay. But we still have to know, right? So go back. Let's click back on that. We don't have a search window until we click on one of those. Is that right?
That's correct. Yeah. And this is where you find.
I see. Okay.
Anywhere in the software where you see 3 dots. I'm sorry.
Okay.
There's more. There
Okay.
are more options.
Okay.
And then you have to learn the German of non-sequential.
Yeah. Well, I think the graphics are pretty clear.
Yeah. Good.
Okay, that's really helpful.
All right, very good. All right.
Because I was going to ask about whether we could preload in some programs, but basically this has preloaded it in
It's
for
pretty
us.
much taking care for you. If you do want to do that, there
Uh-huh.
is this plus. I'm sorry, there is the new save button.
Uh-huh.
We have gotten rid of the floppy disk icon apparently, although you will still find a floppy
Yeah,
disk icon here
load.
and there. But we have the save and the load. So if you wanted to save this one, you can do that here.
Okay.
So if you have users, particularly if you have users doing 5, 6, 7 labels, saving their settings
yeah.
is probably preferred.
Okay, so maybe you can show us, like, I know that this is what my lab's going to use
Yeah. We're going to
50% of the time. So
yeah,
can
we're
we
going to live in this for a minute.
Yeah,
okay, I'm
so
sorry.
can
What
we
was your question?
save? So can we
Yeah.
save this and when I log in or when we log in as users, do we have to go back to where we've saved it to load it, or is there a way to load it into the software itself?
I'm just going to, I think I spelled that correct, right?
Yep.
Janowitz? Okay, all right, great. So we're just going to save that away.
On the C
And that was
drive.
by clicking, yeah, that was by clicking this down arrow.
Okay.
The up arrow will load, and then you would just
Click
select
this.
it, and then
Perfect.
click open.
Okay.
And there are no changes, so it's
Great.
just, yeah.
Okay.
Easy peasy.
So do I get to press the magic button and start?
Yeah,
Okay,
yeah, you
so
do the honors.
I'm
Just click live
assuming,
and-
so right, so can you, so start versus, so I'm assuming it's live because I'm
Live.
going to want to look.
Yep.
What's the difference between live and fast live though?
Good question. Fast Live is a low resolution live preview. The only issue with Fast Live is that it will only show you the setting that you're currently on. So,
okay.
So if
You mean, so if I were in this window instead, it would show me the green, and in this
Bingo.
window instead. And does it switch live? So if I turn it on fast live and then I click on this, does it switch or no?
Unfortunately, no. No.
Okay.
Fast Live is designed for focusing, setting your Z stack, high, top and
Oh, I
bottom,
see.
things like that.
It just wasn't showing it because I hadn't. And do we have to click on it from the top or anywhere in the window?
Anywhere.
Okay, I see. So I'm going to click live so we see all the colors.
Okay.
Okay.
Let's go for
Here
it.
goes.
Okay.
Uh-oh.
And we've got a black screen.
Okay,
Wah,
stop it then.
wah.
Stop,
Well-
stop. Just press stop. I want to stop. I don't want to bleach my sample.
Oh, no worries. Because there's only a 2% laser power, and we're exciting at peak absorption. I'm not worried about bleaching.
Really?
Absolutely.
What if it's really dim?
I'm still not super worried.
Okay, but I guess I could go to fast live mode on the
Yeah.
other thing.
What's a good one? So we on Dappy, let's go
do
to Fast
Dappy
Live,
yeah.
and we're a little bit out of focus, so we can.
Oh, wait a minute. You're using some dials. You haven't told
That's
me about
right.
these dials
That's
yet.
right. I have forgotten to
Oh,
introduce.
and my sample moved.
Well, it
it's
probably
not-
yeah.
Okay.
It's probably the difference between focal planes, between the confocal detector.
no,
and your
it's that
eyepiece.
this is the body. This is where I want to be.
Oh. Oh well.
Oh, but wait a minute. This is a Leica. So
Oh,
it's
come on now.
reversed. So what we see in the eye is not what we see on the screen. So the camera can't show you what we see in the eye, but I can tell you that it's reversed 180 degrees.
It is.
Just flipped, not rotated
That's right.
180 degrees. And so that's really important because sometimes you think you've oriented yourself on the screen, but this is going to be opposite what you're seeing. This is our controller.
That's right.
Of
This
when
is mission
we're-
control.
Mission control when you're scanning. And what's nice is you can change the Z position, so you're basically your focal plane. And we've also had it so you can change, oh, we're doing the XY here, right?
Mm-hmm.
We still use our handy dandy, what did you call this?
Smart move.
Smart move to move in X and Y. So let's start scanning again so I can find exactly where I want to be. Oh, and it's going to be reverse. Oh, that's right. Nope. So I'm going to be going in. This is a germ line. Oh, it's gorgeous. That's like perfect. Okay, and that's actually in pretty good focus for now. So we'll start with the top image because that'll be the brightest. Okay, that's good.
All right, great. Stop.
So we often had problems previously with field illumination. And so, and we really had to be very focused, like the most important thing in the center of the field because there was a drop off right to left. So how much of a drop off do you have?
Good question. When we're at zoom setting 1, which is confocal zoom, it's less than 1% edge to edge.
Oh,
Right,
wow, that's
yeah.
great.
So That's what the documentation says. You may find that there is some slight difference, but there is technology behind this. So every other confocal on the market has what's called just an XY galvo scanner. Leica has an X2Y galvo scanner, and it does make a difference. And that's why we have that spec, because instead of having just 2 scan mirrors, we have 3, and that is the correction that you're.
Okay, but I mean, I think that's really important. So what you're saying is I don't need to worry about being in the center of the field, and if I want to do quantification, I can do it at 1x zoom because there's so little difference
That's
that
right.
it's going to be equally illuminated at the edge of the field as it is in the center for quantification purposes.
Bingo.
So this particular, so there's going to be 2 issues with this particular image,
Okay.
right? So this may be, let's just go through maybe just one screen, and then I want to talk about how to make this image is a little bit bigger, or this germline is a little bit bigger than one field, and so
Got
I
it.
need to know how we can like stitch it together.
Yep.
And then it might be really helpful if we straighten this out.
Yeah. No problem.
And so I know that that's one of the nice things about, one of the reasons we got this confocal is that we can actually straighten out what we want to see.
Yeah, absolutely. Great question. So I will touch on all of those things. So this is just our focus position. We used a fast live to get there. So now if we click live, we can see that build, and we get all 3. And then we'll just go ahead and click stop.
And it automatically shows all 3.
That's right.
Okay.
Right now, and if we want to overlay, there's an overlay button right here. Just click overlay, and that's what it looks like. I can double click to bring that full screen, double click to.
So if I double click in just the DAPI, it's DAPI.
Yep.
And then, hold on, go back to that. So if I click here and turn on channel 2,
It gives you
now
the
it's
overlay.
both. And so if I want just channel 2 or just channel 3. Oh, nice. Okay, so this is where the magic of confocal comes in. How do
Yeah.
we get rid of background? Like, well,
That's right.
maybe we need to finish going over this
Yeah, we
stuff.
do. We absolutely do. So in this case, we have an image on the screen, but it's not optimized by any stretch. So
Right.
let's do that briefly. So let's go ahead and click live, and right now I can see signal, but over here I have my display range, and I can see that I'm only filling half the range on blue. On green, it's like 20% of the 10% of the range.
Oh, so it's from the bottom up how much of the
Yeah.
range.
And
Okay.
yellow is about 5% of the range or
Okay.
less. So not much signal.
So do we want to fill the whole range?
The goal is to get this almost full, or full.
Is
if
that,
possible.
and that's intensity, or is that?
Yeah, so there's a couple of
laser
different ways to do
power?
that. Yeah, there's a couple of ways to do that. So we can do this by just,
Hold on, can I ask one more question?
Yeah.
Can we just do it right now it's still shining, even though you're adjusting. Sorry, can you turn it off for a second?
Yep.
So you have highlighted this window.
Yes.
So you're adjusting just the DAPI
Just the
window.
DAPI.
But again, I know you're not nervous about bleaching, but I'm nervous about bleaching. If I undo these, will it actually turn the lasers off while it's imaging, or no? It's still always doing all of them.
It's always doing all of them.
Ah,
Yep.
okay.
Yep. So by default, the laser power that activates is 2% laser power. I personally have not experienced photo bleaching at 2%. That said,
Yeah,
I haven't
mean, we've never
worked
really
with your
experienced
samples.
it at that. So, okay, so can we, because I saw you starting to touch these.
Mm-hmm.
So can you just tell me what all these buttons are? So I see this says zoom.
Yeah, this is your confocal zoom. So this is
So let's turn that one on and let's just see what the zoom button. Can we just go through each of the buttons one at
sure.
a time?
Yeah, of course. Smart gain and smart intensity. Smart gain is called smart gain because it's going to amplify the signal that's received at the detector.
So that was basically what you were doing there. Were you
that's
doing
right.
gain or intensity?
I was doing gain, and
Okay.
so it's called smart gain because smart is linked to the panel that you're currently on.
I see.
Intensity is a German way of saying laser power,
Okay.
and smart wavelength is, again, it's going to change here.
So I don't think we need smart wavelength, but we do want to have the scan field rotation.
Scan field rotation.
How do I change that? Because I really want to have it, and I understand that it doesn't come up automatically.
Yeah.
Okay.
So
This is really important for us.
yeah, absolutely. So in this top panel where I told you you're not going to be doing a lot of clicking, you won't. This is really the only place where you'll visit,
Okay.
which is this icon of the panel box.
Oh, yeah.
And then we have the panel box.
And I presume this is speed.
That's right.
Oh, good,
Yep.
because I want to change one more thing here. So we just need to click here.
Yep. Change smart wavelength to scan field rotation.
Okay. Can't you just save it? And that saves?
Yeah, unfortunately, I can't. I mean, I can type in. No, we'll type in.
That's fine. Yeah. Okay.
Okay.
I also want to default this. Does it go smaller?
Absolutely. 1 micron.
Oh, and we can't do anything in the middle. Those are presets.
Yeah.
Okay, we're gonna do it at 1. 10 was way too much.
Too much. Okay.
Okay.
All right. Okay. All right. So there's a couple of different ways to enhance signal here.
But I do want to say something. So
Yes.
if somebody else is coming, and they have really thick samples, they may want to go back and change this to be 10 microns for their
10
user.
or 100. I don't
Yeah.
know why you do 100.
I don't know
but,
why you would do
know.
100 either. But they may want to change it to 10 if they have really thick samples.
Yep.
Okay. Because we surely have users who will use that.
That's right. All right.
Okay, so Z position
This
is
is your
focus.
focus.
This is if I'm zooming. Can we see what happens live when I'm zooming?
That's right. Yeah, no problem. Here, let's do a fast live because I'm impatient. So let's do fast live.
Okay, can I do it?
Yeah.
Ooh, I'm excited. Oh, let's do it like that. What do you think?
Okay.
Okay, we're gonna do that. And then I want to move it again to be a little more centered. Oh, and I can do my scan field rotation. Let's do that first. I'm so excited. And I know I want to, this is one we need to make faster because obviously this
Yeah. No problem.
is so exciting.
So when you go to adjust it in the center,
Now it's going to be a weird way to do it, I
yeah,
know.
it's gonna move a little funny.
It's okay.
It's all right.
Okay, that's
right,
great.
that'll
And
be
maybe
fun.
I'll zoom up a little bit more because we're going to get we're going to get beautiful images. Oh my
Okay.
God, I'm so excited. Okay.
All right. So let's.
And you said I don't have to worry about putting that in the center, even though it's more aesthetically pleasing.
Yeah, we can correct for that. So actually, you can actually stop. So we haven't talked much about this menu right here.
Oh wait, so let's stop if we're going to
So
stop.
let's go ahead and stop.
Oh wait, stop? Oh, because it was fast live.
Yep.
Okay. Can
So-
we get it in focus so I can just go live again?
Mhm.
Can I thought we were going to set our intensities.
Yep.
Oh, I want to go this way.
And we are getting some vibration from the room.
Oh, that's
So
what that is?
Yeah, I've got to adjust the table.
Oh, okay, that's good to know. Okay, so we were adjusting the intensities, and I didn't understand when you choose to use gain versus smart intensity, and we need to adjust all of them.
Yeah.
If we can.
So all right. So let's go ahead and do that. Let's go live.
Okay.
And let's look at these. So blue is pretty good.
But I thought you said I had to. How high up should I be coming?
Yeah. So I'm going to go ahead and apply a little bit of gain. So go ahead and adjust it a
gain
little bit.
as opposed to, ooh,
Yeah, that's a lot. So down around 5 is probably all you need.
this was, so we can maybe make this one a little bit slower on our speed.
Yeah. So that'll be good. So something in this range is really good, in my opinion.
Oh, like when you say this range, you mean,
222,
Okay.
215, 230.
okay, so maybe we want to make a note or a little cheat sheet where we say the range is 220.
Yep.
For gain, right?
Yeah.
For that.
For that.
Right. But you're saying, and I don't want to play with the laser power because I didn't need to increase it for this particular image
That's
to
right.
get it to be in that range.
Bingo.
But if I couldn't, like maybe with this one, which was dim,
we
but it
will
isn't.
we will
we
apply
won't
laser
actually
power.
because these are foci and they're actually fine.
That's right. So on green we only have 26, and
Okay.
so this.
So I'm a little bit concerned with the green. So what I want is these nice fine lines, but some of this other stuff is background. How do I know what's background versus real?
Yeah, good question. So we can tinker with that a little bit. So I'm just applying a little bit of gain. If I go up above 20%, I will typically then start to adjust laser power.
Yeah, I see. So now you're at 21%. We're still not all the way up. I see.
So now I'm applying a little bit of laser power, and we're right in the
I see.
range.
Good. Okay, but we still have a lot of background.
Absolutely.
Okay.
And so there's a couple of ways that we can tackle this. Remember how we were adjusting this?
Oh.
We can just start to close this down, and maybe we're getting some not real signal.
Oh. I mean, it may be real. It's
It could
possible
be
it's
real.
real, and we just always call it background, and there's really something there that we didn't know was there.
Yep.
We didn't think was real.
Yeah, it's hard to say.
Yep.
There are some other tools in here as well that we can look at. All right, so let's come back to live again.
So this is actually, those are pretty good. I know that this is low. I'll increase it to see what happens, but those foci are different, right? It's not the background that I want. So like if I were to go all the way up, to 20,
Yep.
I guess my foci are better, but I also,
You're also getting some background, and so
yeah.
And so again, this well, we already have this closed down pretty well.
But I don't know that I need it since I could see the foci, even at the low. Yeah, so I don't know that I need it higher. Like even though this isn't up at 220, I see those foci just fine.
Yeah, it's just not a great dynamic range because if I take this to the location where the other ones are at, then we don't see it as well. It's just not balanced. It's not balanced. So
I see.
It's kind of up to you. I mean,
And you're saying but how? Oh, and I didn't have to increase it that much to get there. Oh,
so
okay.
I had applied, and I probably didn't mention this. I had applied this auto scale. The auto scale will automatically adjust to.
I see. Make it look good.
Yep.
I see. So if we unclick it.
Yep.
And then turn it on.
So if I click the reset button and go full display range, this is what it looks like, full display range.
Oh, I see. So I might want this. How come it doesn't show any? Oh, it's at 255?
Yep, it's a full display
range.
range.
Oh, it is at the full
Now I'm auto scale.
I see. Okay. But I might want to, what if I thought this was still dim?
Yeah, you can apply gain or laser power.
I see. So like that might be better.
Yeah.
Is that too much gain though?
No. No. Anything under 100 is fine.
Oh, okay. That's good to know.
I typically try to keep it under 50, and if I can keep it under 20, I really feel like I'm winning.
Well, that was what I was wondering. So, I mean, I'd rather not. I start to then worry about bleaching, particularly for foci. But if 50 is fine, then I think this is much better.
Yeah. I
okay.
mean, all right. So now we're doing well. Okay. We can do a couple of things now that we have.
Oh, I know. So for me, we really like everything being super high resolution. We haven't talked about resolution. You were going to go back here,
That's right?
So we have to talk about resolution, and that's going to change our intensities, right?
A little bit. A little
okay.
bit. It'll be all right.
Okay.
So in order to, now that we've optimized illumination, now we need to optimize our scan, our resolution,
okay.
right? And so in this case, we have something that's kind of long and narrow. We can increase our resolution by clicking this menu right here.
Yep.
And
this is really the same as DPI, basically.
That's right. Yeah. There's actually some. So the software gives you the tools to do the math on your own to make sure that you're really optimized.
Okay.
Or the software can do the math for you, which
okay.
is helpful. In this case, we can click this optimize button, boop, and 752 by 752 is actually
optimized. The optimized pixel size for that.
Bingo. For your zoom setting, for the objective lens, for everything that you're using. Okay, and then...
But if I wanted it to be higher resolution, is this actually resolution?
Yep.
Okay.
Yep, and you can go higher if you want. There's no benefit.
I know. It just makes it always seem like there's a benefit. It seems like if you then want to make a poster.
Bingo. A poster.
Right.
Yep.
which often we are, publication quality, we want higher resolution.
And that's fine.
So you were going to say, though, that because my object is long, I don't
Yep.
necessarily have to have this be square, because I
That's
don't
correct.
necessarily want to collect the black.
That's right. So you can do like a 1024 by 512. And now when I
that's-
click live, and now I can just like nudge it down a little bit.
Oh, that's nice. Oh, and it knows what it knows what the window is.
Bingo.
Oh, I don't have to do this whole crazy thing here.
No.
Oh, I like that.
Yep. Because
Okay.
we've zoomed in to 4.21,
Yes.
so we're really only taking a very small
Yep.
portion of the field.
Cool.
Okay.
That's awesome.
All right.
Okay.
All right. So now.
And you turned it off.
That's right. We are not scanning anymore. So our format is good. This is beyond the resolution, that is optimal. So we're oversampling, which is fine. Speed is 400, which is, fine, but we can go up to 600. I like 600 more.
Well, what does that mean? But there was more options. How do I know?
Good question. I generally tell people to stay at 600 hertz or below.
Why?
Unless you're doing something live, like live cell, something like that.
What if you're doing so we have a couple users who really are doing very big samples.
Got it.
Right? I can think of, say, Pam O'Malley's group looking at uterine tissue, or maybe Miguel looking at a whole ovary, or Kyle's group looking at a whole testis. If we wanted to would we do faster scanning for really large samples?
You could. When you scan faster, the scanner actually zooms in a little bit. So when we go to 700, it'll zoom in to, I think it's 1.25. When we go to 1,000, it's 2.25 zoom. So there is kind of this like.
So basically, even if it's twice as fast, if it's zoomed in twofold, it's basically the same speed.
Bingo.
Okay.
Yeah, there's very little of it, particularly for large stitching
Okay,
applications.
but you said, when do we want to use the higher speeds? You said
Just as
bleaching.
Well, it's just out of patience. Like I don't have a lot of patience, so I like to go as fast as I can. Really, my standard is 600.
Well, is it going to compromise, in this case, because I have this other stuff set, is it going to, and I'm already on 4.2-fold zoom, so can I go to like 1200 and
Yeah,
not
you can
change
go.
it?
Yeah, you can go to 1,000 if you want.
Well,
or,
yeah,
or let's see, what does 1400 do? Okay, it zooms in a little bit.
that's fine in this case. Okay,
Alright.
let's keep it there. We're going to be fast.
All right, let's crank it. Okay, so
Oh,
we've got a resolution.
wait. I like to work my way down. What is zoom in? I'm sorry. Oh, so instead of zooming here, we can zoom here.
Yeah, so the zoom factor, you can type in a number. This zoom in button.
So that's basically, so if I know for all my samples, or last time my sample was at 2.5x, now I want to do exactly the same thing here,
Repeatability.
rather. Okay, perfect.
You just type it in.
Okay.
Zoom in is really helpful if you have something like on the screen that's off in the corner. You can click this on and draw a box on the screen, and it'll zoom in on that spot.
Oh, we're going to do that later.
Okay. And then this is the information that
Yep.
I was talking about before. Pixel size.
And all of this is kept in the information
In the
that you
metadata.
collect in the metadata. Great.
All right.
And all this is, and that's basically, and the speed, or no? They don't care about speed because it doesn't change resolution.
Yeah, in this case, frame rate doesn't really matter. We're dealing with a fixed sample. If it were
Okay.
live, or if it were dynamic, we would care about frame rate.
Yeah. Okay.
And so lots of things change the frame rate, like the number of pixels
Yes.
you have, as well as these other functions like line averaging. Line averaging reduces noise.
Right, so maybe, so this, I don't know what ACU is. I surely know, I'm assuming when we're talking about averaging, we're going to talk between line and frame averaging. And so maybe you could tell us what line and frame averaging are and do, because I think that's an area where we haven't really taken advantage of that
Yeah,
so much.
totally understand. I mean, line average is what it sounds. We're going to go line by line. So we're going to acquire 2 lines in each channel. So blue, then green, then red. We're going to acquire 2 and then step down. Acquire 2 and then step down. And what that does is, your real signal will stay stationary.
Right.
Any noise is random. Noise is random. It moves around.
Right, so the idea basically is random noise is basically going like this.
Yep.
And the probability that it will blink at the same position twice when the line goes over it
Super low.
is really low.
Yep.
So why would I do line versus frame?
Good question.
Speed?
Speed, exactly.
And in this case, is line faster still?
Yes. Yep.
So confused by that.
Yeah.
So counterintuitive.
There are very few applications where frame is faster.
Okay. So we're going to do, so because this, and we have to do it for all of the channels, right? I can't choose that only the green is going to be line averaged.
Line average is going to filter out the noise. Line accumulation is kind of the opposite. So
Oh, if it's really dim, it does it twice.
bingo.
Okay.
It's additive. And so I use this a lot with weak signal.
Yeah.
Where my laser power is uncomfortably high, I back off on laser power. I do accumulation.
Yeah. Okay. Okay.
And so
that makes really sense. So that makes a lot of sense. So, Michelle, you're making some live transgenes, right? Which might be dim, and there it's really important that we keep the laser power down. So you might use this line accumulation.
Yep.
Right? Okay. Okay. So let's talk about. Let's do a single frame. So if I just want to get that single beautiful frame, what do I do?
All right. So I mean, we have the resolution. We have the all the label is set perfectly. It's right where we want it. So now we just go ahead and click capture image. Like if we just want a single
plane,
nice image. With
Okay.
a little bit of chatter from vibration.
Yep.
It is what it is. All right. And so now if now that we have the setting set up, we have the resolution just the way that we want it.
Yep.
It's perfect. It's beautiful. Adding a Z stack is really, really easy.
Okay.
So
so this wasn't. Was this on initially,
It
or was
was.
it? This one wasn't. So
That's
you had.
right.
I see.
this
so there's
one
a little
was
carrot next to it.
shrunk down. I don't know why.
Okay, because you
But-
would think. Okay, so now Z stacking is done here,
That's right.
and so my understanding, right, is that begin and end is basically we're gonna move our Z position up
Yep.
and down with that scroller, define a beginning spot, click it, scroll down, define an end spot, click it, and that's going to be our two positions.
Exactly right. So
Okay.
I'm gonna do this in the green channel with Fast Live.
So maybe Michelle or I should do this because we actually know what we're looking for. Do
Sure. Yeah, if you want.
you want to do it? Okay. Can we turn it off so she can
Yep.
also turn it on? Okay. So once you get, so you want to turn it on the Fast Live mode, and I think. So we had a problem previously that there was sometimes we see a shift in the Y. So do we need to over collect above like the top or the bottom? Do you recommend that?
Yeah, I mean, why not? Sure, we can go a little bit above and below.
Okay, so a little bit. So this is confocal. So, yep. And now you want to use the Z position to, and this is going, and you could go pretty dramatically fast in one direction. Ooh. So keep going, up. Yeah, so we want to get rid of all that until you see it really gone. Okay, that's good. And then I think we should be able to get into the middle. This might not have been the best. There we go. Yeah, there you go, right in the middle. So we don't want the ones coming from the bottom. It's a tube, right? So, yep. Which you were turning this way. So like right there. Yeah. Okay, and then turn it off. Okay, so this is system optimized.
Yep.
Did it automatically, since that's clicked, did that change?
Yeah. So System Optimize is going to calculate the number of steps that are required to faithfully represent your data in 3 dimensions.
I see.
So you can change that though if you don't necessarily.
Yeah, so it was doing it as 0.3. So if I wanted to do a better, so we like to do so when you click here, see each step size, and we want to do it at 0.2 microns because that's what we like to do for our public, since the chromosomes are so small.
0.2
Yes.
because
Yep.
for whatever reason the software.
And then
doesn't do that.
enter. Yep. And now it went up.
All right, so you're basically ready to go, and you can go ahead and click not capture image, but start.
Yep.
Start will activate your Z-stack, time lapse, whatever you have in there.
Ooh. And it's black at first because we had over collected.
Yep, you went above.
Oh, and now we
That's fine.
start to see our sample coming. So exciting. Right, and you talked about how it's basically like literally like a printer. So what we're seeing
Yep.
is it going down each field as it's collecting. Ooh, the foci are so pretty. Okay, so now it's done, right?
Yes, sorry,
Okay.
I'm very, very concerned about the table.
I understand.
Okay, all right, so now it's done. And so, yep, look at that. You have intuitively figured out how to pan through in Z.
Right, so this scroller right here is the panning through in Z. Do you want to move it up and down? Ooh.
Very nice.
So
Okay.
let's double click on this one. So now, oh, I see the movement.
Yeah, lots of vibration.
Yep. Yep. Great.
Okay.
Okay.
All right, so let's go ahead and look at this in 3D. Do you remember how to do that?
No, we didn't talk about that
Pan
really.
pan over to the right with your mouse. Click the 3D button. Beautiful. Wow, fancy,
Ooh.
fancy. So I don't know why the gray background is preferred.
I don't know why it came that way either.
But there's a checkbox over there on the left that says black. Down a little
Where?
bit. Up a little bit.
Oh, here. Background black.
Perfect.
Yeah.
Now you can click that and move it.
So rotate it. Yeah.
Look at that. Oh
Ooh,
man.
Nice.
Beautiful.
Yep. So if we wanted to try to, can we post facto get rid of some of the background?
Yeah. So in the settings in 3D are just kind of auto. They're auto scaled.
Yeah.
In which case it looks like the yellow kind of has a lot of background. So click on the yellow tab. Beautiful. And then do you remember?
And if I want to change the color,
Yep. Click that, and then you can choose a color.
make them magenta.
Double click.
Ooh.
Or, oh, okay, I'm sorry, close.
Yeah.
Yeah,
Oh, nice.
all right, so now the three.
So hold on one second. I'm going to just change the colors. I know it's fuzzy. Oh. Okay. Much better.
Okay, all right, you feel.
This way it can be seen better on the screen also.
Okay. Very nice. Okay, so
So if we want to adjust, say, the pink channel because we can't see it well,
deselect the checkboxes.
all of them, or just the other two?
Just the other two.
Oh, and
so
then
you
we.
want to. Okay, so you can adjust it with the minimum and maximum, or I like to adjust it with the histogram, which there's 3 dots next to the. Yep, perfect. And then.
Oh, that's helpful.
Mhm.
Brighter. And that gets rid of some of my background. Oh, nice. And now I can add back the DNA. And if I want to not be able to see the DNA as intensely, oh, it's drat. There's no undo, huh?
Sadly. You're still on the pink tab.
Oh, I have to switch the tabs. Oh. I see. Oh, much better. Oh, cool. Okay, this is great.
Well, yeah, you're adjusting the green, but you're on the pink tab.
Oh, I was
There it is.
on the pink. But it doesn't, does it change the green if I'm not on it?
No.
Okay, good. I mean, if it's not checked. So here, it won't change the pink, but is it changing the green if I'm on the green tab if it's not checked?
Yeah, yes, it will change it. You just can't
okay.
see the change.
Okay, so this changes how we see it. Okay, so how do we get away, how do we get back to our normal image?
Sure. Yep. A couple things in here that I wanted to show you briefly. Lots of people like to rotate and look at it in 3D. And then also a lot of people like to create little movies. for lab meeting, that sort of thing. So
Yeah.
it works based on keyframes. There's this movie editor checkbox right here.
Oh.
And then we'll just click add, add, add.
How did you zoom in? With the scroll bar?
With the scroll wheel on the mouse.
Okay.
And then we click this preview.
Oh, and it just goes, it doesn't do the whole switch, it just does it as Quantal, and it figures out the right way to get between those. That's cool.
And you can add more so that it's smoother, more frames. So now it'll move a little more smoothly, a little bit slower.
Okay, and how do we export, save and export our movie?
Good question. So down here, there's a save button.
Yep.
And then you can save it as I recommend MPEG-4.
Okay.
And then you can do like a HD movie,
Okay.
which is also a great idea. And then you just click OK.
Yep.
And it'll
Save it. Right now, save it to the
somewhere.
desktop.
Yep.
Demo. Oh. Okay.
Great. And you can see it saving down here.
Yep.
The other thing that people really like is this clipping function,
Ooh.
where you can
Ooh.
do digital sections. Very nice.
Right, if you want to look at the middle of a tissue or the middle of a nucleus or something.
You got it.
And this is really great if we're counting foci
Ooh.
that we would move. That's awesome.
So there's your foci.
Yep.
All
Oh my
right.
God, that's going to be so easy.
And then
Can we mark objects too in here? Like, so if we were actually counting this one, can we mark that we counted it?
ooh, good question. I'm not sure.
Okay.
I don't.
Maybe
think
that's the
so.
advanced
I
technique.
don't think
Okay, so
yet.
for now, the clipping is helpful.
Okay, and if you want to get really fancy,
Uh-huh.
let's see, you can.
Oh, clip some channels and not others. We're not going to deal with that for now. Okay.
Oh.
Oh, that's cool. That's actually really helpful. Clipping, and you only had to clip the red channel.
So under here, channels,
Uh-huh.
you would make the yellow channel. Just click this transparency box.
Oh, that's awesome. This is really how you count foci because you can move it
You can move
across.
it
Yeah. Oh my God, this is going to change our life.
in and out. Okay. Well, I've never changed anybody's life until today. All right. So to get out of the 3D viewer, even though this is so much fun, we just want to live here. We can click this
Okay.
X here. So we're going to be going over Lightning Super Resolution. It's a module in the software that allows users to go beyond confocal resolution. The way that it's done is by optimizing acquisition, followed by post-processing deconvolution. And so the software is designed to help users do this quickly and easily without having to make a lot of changes on their own. There's a simple slider that allows users to choose the speed or resolution that they want, choose their mounting medium, and then acquire the image. And when you're done, you have a beautiful high-resolution image, high-contrast image that is able to resolve things down to 120 nanometers. So it's a great menu, and hopefully you guys get a lot of use out of it. So now we're going to jump into super resolution technique, which is called Lightning. And within Lightning, we can really optimize the resolution of the system. The idea is to go beyond the diffraction limit of light, which is why we call it super resolution. Breaking the laws of physics here, and you don't even have to give it a whole lot of thought. So in order to do that, we just go ahead and click this Solaris 5 button, come down to Lightning, and it will load a very similar looking menu. You might be asking yourself, what has changed? Only a couple things. Up here, there is this new panel called Lightning Grade, and then we have another new panel called Lightning Settings. Okay, and so what we're going to do here is adjust this slider, because if you're like most other users, you push this all the way to the right and you say, I want maximum resolution. I would encourage you to, dial it back a little bit. Don't go quite all the way there. And when you make these changes, If you look down to this panel over here, you can see that there are a whole bunch of things changing. The format, the speed, and one thing that we haven't really talked much about, but the pinhole. Okay, and so the pinhole is a critical step in this process, and that's going to close automatically, and it's going to close as a proportion to the slider that you selected. Now, you might be looking at some of these settings and saying, oh, well, this is great, or this is not great, like I want to make some changes. And if that's the case, you can always unlink the two and do things like, I don't want to do quite so many line averages because I'm not patient. I'm not a patient person. That's fine. When I switched into this lightning menu, my Z stack was preserved. My acquisition settings were preserved. Everything is still ready to go. And so now, in this case, I'm actually going to choose system optimized because Judy was saying, like, we like to acquire at 0.2. Well, when we close down the pinhole, the Z step size will change as well. Okay, and that is true in the other menu as well. If you close the pinhole, your Z step sizes will change. Okay, so now we're ready to go. We can, let's see, how many slides? 21. Ugh. Do I want to sit through 21? I don't know. I'm going the wrong direction. I don't think I do. So I'm gonna make it a little bit smaller just so that we get the idea. Okay, so we're ready to go. We can click capture image, or you can click start experiment. Let's go ahead and start. Oh, and it's going to do some math here. And basically the goal of this, what's going to happen here is we have optimized acquisition so that once we have an image, we have excellent data for the post-processing deconvolution. Okay, so the deconvolution step will happen automatically. You don't have to worry about it. It just happens. And there are some menus in here where you can like dive in and make some changes. We're probably not going to get into that today. Here, let's set our auto scale. Looks like maybe I clipped off the bottom end when I should have clipped the top end. But it's starting to come in. Just 32 seconds left. In that 30 seconds, I'll just go ahead and tell you that lightning deconvolution is unlike other forms of deconvolution where the deconvolution is applied the same across the image. In this case, the algorithm is designed to process areas of high signal to noise differently than areas of low signal to noise, which means that it's adaptive. It will adapt to the image data to process it in a suitable way for that, I guess, image, right? So it's a little bit smarter, and that's unique to Leica. Leica is the only one that's doing that right now. So let's go ahead and do our auto scale so we can see stuff. And whoa, look at that, totally different. So if this is my process data. If I come over here to, I'm gonna add, by clicking this plus, I'm adding a second image viewer. I can come over to Open Projects, select my raw data, because the system offers you raw data and process data. And I can zoom in and say, wow, that's incredible. And actually it is, because look at all that noise and chatter. Jeez, oh Pete's, this air pump really needs some help. But you can see, like, that is really incredible. It did a really nice job of cleaning that stuff up.
So I know on the wide field scope, you could kind of apply the thunder in processing. I know this is a different thing. Can you do that, or should you take it at the same time as you're taking the image?
Great question. So on the thunder system, optimizing your acquisition is not nearly as important. So I would say new users use the lightning menu. But you're right, you can acquire a data set, whether you're in Lightning or not, and you can always come back to this Lightning tab and process your raw data separately. So in this case, you would do something that you would say adaptive, yes. What is the mounting medium? I don't even know. What do you know what these are mounted in?
It might be prolonged gold.
Prolonged gold. So we're going to choose our mounting medium, and then we'll go ahead and we'll just leave all those settings the same, and we'll click apply, and it's going to reprocess the image. Actually, I think I might have, no, I didn't. I thought maybe I processed the processed image, but at any rate, okay, so look at that. Is this, are there differences between the two? A little bit, because this one I forgot to select the mounting medium, and this one I selected prolonged gold. And so you can see it did a little bit better job because it had a refractive index match. And so anyway, there are lots of little controls in here that allow you to get in and make some changes and experiment with, what looks good, what doesn't, try to optimize it. I think for most users, getting into this menu will only cause problems, all right? But once you are familiar with it, maybe in an advanced training session, you'll learn about it. Or you'll notice there are these little red dots throughout the software. Click on the little red dot, and after you accept these security things with Internet Explorer, you can read about what each one of those settings does, okay? So leisure reading, in all of your spare time, you can read about that. All right, so acquire, getting back to where we were before, zooming out. All right, so let's go back into our just non-Lightning menu. But staying on the Lightning topic, I also wanted to point out briefly, here in the Process tab, I had mentioned earlier, we're not going to spend much time in the Process tab. That is true, but there are some process functions in here. Okay, so Lightning Process, this is a familiar menu. So if you have data that you want to apply Lightning to, is this a Z-stack? Yeah. I can select that Z-stack, come to Process Tools, Lightning Process, let's see, choose Prolonged Gold, and then click Apply. And so even though I didn't use that Lightning slider to optimize my acquisition, it's probably pretty close. And so we're going to get some enhancements out of it. So if you forgot to use Lightning, or if you were doing some other experiment where you weren't able to use Lightning, you can always come back, reprocess it, it'll improve it. Cool? All right, so I'm going to navigate back to my Acquire tab. And now I am going to reset some things. I'm just going to take this back to 0. 0 on my scan field rotation. I'm going to delete my Z-stack. And I am going to go into our stage navigator. A couple things I want to reset my pinhole to 1. I want to change my speed to 600. I want to set my zoom to 1.5. When we're doing stitching, I really like to use a zoom of 1.5. Usually produces great results. We do 512 by 512. We can keep our line averaging. Okay, all right, so now we're going to jump into Navigator. Navigator is our stage, like stitching, whether you're doing stitching or multi-positions or Z-stacks with stitching or multi-positions with Z-stacks and multiple colors. Like Navigator is going to be your, we'll call it stage experiment tool. So sadly, there isn't a better icon. They chose a square with a grid, kind of a sad icon. All right, so we're going to click that icon. Should be something much more dramatic for what it does. All right, so I'm just using the mouse wheel to zoom in and zoom out. It's kind of a Google Maps view. If I zoom all the way out, ooh, you can see the entire stage travel area. And that tiny little dot there on the screen is where I'm located. And I'll zoom in. Or if I don't want to zoom in, I can click this thing, move to stage position, zoom out. Okay, great. So now I'm going to do what's called a spiral scan. It's going to start from the center and build out. in a spiral. That's why it's called spiral scan. And so now we're starting to get perspective on other structures in the area. Okay, and this is nice, but I'm impatient, if you haven't learned. I don't have time for this business. So I'm going to go ahead and click stop. And I am going to come to scan mode. And I am going to activate the resonance scanner. Dun, dun, dun. We haven't talked about the resonance scanner. There are two scanners on this system. There's the resonance scanner and the field of view scanner. We've been using what's called the field of view scanner for the last, basically up until now. This is the preferred scanner for 95% of applications. There are some applications where a resonance scanner can be really helpful. Live cell is one of them. Large stitching is another. There are trade-offs. The resonance scanner is incredibly fast, which means you spend less time doing stitching. But also when it's incredibly fast, it means that you're not collecting as much light, you're collecting more noise, and so your image quality isn't quite as good. And I think you'll see that here. So let's go ahead and activate the resonance scanner, and that whine lets you know that yes, it's working great. And instead of a line average, I'm going to do a line accumulation. Actually, you know what? I'm going to do a frame accumulation because this is one of the few cases where frame actually works better. And let's go ahead and do a spiral. So a little bit faster, aka a lot faster. And so now we're getting a nice perspective of what's on this slide, which is not much. It's pretty, a lot of open space. I was hoping we'd catch another worm in here or something, but that's not, doesn't look like that's happening. It's just junk. Okay, well, we'll let this run for another minute, and then we'll just cancel it if we don't get anything else. You can see down here the progress bar. This tells you, when you've reached the limit of how many you can acquire, or how long you can acquire, I should say. All right, well, no luck. All right, so I'm just going to go ahead and stop. And I'm going to come back to my scan mode, familiar menu. I'm going to deactivate my resonance scanner. And I get a less annoying whine. Okay, and let's turn off our accumulation and go back to line averaging. Okay, close. So now I can zoom in on this area. And Judy was mentioning, what if my object is larger than a single field? Well, we have that exact problem here. So we can do a stitching routine. In this case, we'll just draw a polygon in the area that is interesting, which I believe is this area. Right-click on the mouse to close it out. And you can see, like, I'm not going to acquire this panel over here because it's just not needed, which is great. So now, let's fast live and make sure that yowzes. Looks good. Do you normally, like, look at the top?
I haven't looked at any germ lines. I just look at the worm as a whole so far. So I couldn't tell you because this is like the extraction.
Okay. All right, no problem. No problem. So we're just going to do a single plane, and that single plane is going to take 27 seconds, which sounds great. So let's go ahead and do that. And now you can see a building. Fantastic. It's done. Okay, and so this preview image is not the final image. This is just being what's displayed on the screen. You can, in order to see the final image, you need to visit Mosaic Merge. Click here. And then we have the same, a very similar process to Lightning. We have a raw data here. You can see that frame was not acquired. But then the software merged those images, used a contrast-based stitching algorithm to like line them up and make sure they were perfect. And then it's going to add in a black panel. That way, it looks good. It's ready for publication. Great. Okay, and then we can go back, and you might be looking at this image and saying, oh, this looks pretty good, but you know, I'm at one focal plane here, I'm at another focal plane there, and a totally different one here, right? So if that's the case, you have a couple of choices. You could do a Z-stack, which in this case would probably be preferred, but what I wanted to show you is that you can also do focal points. So I'm going to click this blue F. We're going to click it here. I should have moved it. We're going to click it here. And we're going to click it there. And now we'll visit this thing called Focus Map. Double click. Let's go live. And now let's pick a focal plane. We're just going to pick the top of the gonad. Set Z next. Need to click Fast Live. It's a bug where it set Z next. And the reason why I said a Z-stack would be preferred is because there's so much movement within a single field, it's going to end up looking goofy. It's going to end up not looking correct. Set Z. All right, so now we're going to go ahead and acquire. And if we watch our Z position, it's going to acquire that first image, and that second Z position moved, right, to try to address the focal plane differences. It's going to move again. Again, this is to address focal plane differences. Okay, and you can already see there's going to be a problem here because that's out of focus, that's in focus, and they're right next to each other. Looks like garbage. Let's see how it turned out here. Not too bad. It's a little funny right there. So there are some tools that you can use, but really what I would recommend is just doing a Z-stack. Clear Z. Actually, I'm sorry. I want to remove all. Remove all focus positions. Yes. All right. So in order to add a Z-stack, super easy again. We'll just, choose the top and the bottom, apply it, and then it'll apply Z-stack to the tiles that I've already assigned. Easy peasy. All right. Well, that is kind of the basics of Navigator. There's so much more that you can do in this software. You can do multiple positions. You can do multiple stitched positions. You can do multiple single images. You can do time lapse, Z-stack, multicolored, anything that you want to do can be done here. And in this case, we have a slide. We can do this and get perspective on where we're at with the slide. So just kind of a helpful graphic to give you perspective. Again, it's Navigator. All right, so now we're done with that. We can go ahead and click close. Don't click the X. Click the close button. It's important. And we're back to that menu.
Okay, so this is our beautiful lightninged image.
That's right.
That's right.
So here's the,
Oh, wow.
raw data
That's amazing.
versus the lightning data.
Yeah,
I mean,
Really
I'd say it's a pretty big difference.
it's amazing. Can you put them both in 3 dimensions at the same time by clicking in the 3D?
Absolutely, yeah.
Do they have to be linked? Oh, you linked them already.
I think in the 3D viewer we need to create another panel,
I see.
and
Oh,
then we can
go to the
come down here.
series 2. That's the lightning one.
There we go. So this is raw.
Raw.
This is lightning.
Oh, and then we can rotate it around now in.
Yeah.
Oh, but they're not linked.
Oh, click
Thing.
click the. There it is.
Ooh.
Pretty significant, particularly in 3 dimensions.
Yeah. The other thing that's important to show people is that, like, the registration in Z is really important. So what we're not having is like the green way above. We're not having a green shadow or blue shadow
Got
or
it.
whatever, right? So, and then in this, we talked about making a movie, right?
Mm-hmm.
Um,
So in the 3D tab,
We want to do make them. Oh no,
Click-
we could
yeah,
do
click-
clipping. I want to do clipping, for example. And if I was just going to clip and keep the yellow, how do I start the clip again? I forgot.
yeah, it's okay. So you can, like, whoops.
Right. I just want to know how I move the clip. Oh,
It was hiding.
I see. So it's somewhere in. How did you know where it was?
I just had to get to the right orientation, and then the red line became available.
I see. Ooh, that's so. Oh, this makes it. It's going to make counting so really. That's amazing. Okay. Right. So now we can look at this nucleus and be like, ooh, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's awesome.
Awesome.
Yep.
I love it.
Much better than on that side too.
Yes. Yeah. Lighting does a really great job of clearing out the background and enhancing the real signal.
Yep.
Yep. No doubt. So
Okay. So can I make a movie of the clipping?
you can. It's a little more tricky, but if we come to movie editor, I need to come to settings over here, and then select this clip planes edit, and that will show us a movie
Going back and forth.
of this going back and forth. That's right. And actually, if you see the 3 dots right there, you can even change the pitch and the yaw.
Oh, nice.
So that, because this is at an angle,
Yeah.
we can try to get it to match
I see.
the angle of
Yeah. I
this.
see. Yep. Cool. Oh, look at that. Ooh.
So closer, not
yeah,
perfect,
that's
but
it's good. That's great. Okay, that's really helpful.
But once you have that set, then you have to.
Right, and you start, and then you go to the next place where you want to stop it.
That's right.
Got
Exactly.
it.
Yeah.
And maybe you then rotate it.
Add.
Got it.
Rotate.
Got it.
add.
Yep.
Move it,
Add. Perfect.
and then preview.
Oh, nice.
So that's really helpful for lab meeting
Yeah, no kidding.
and or impressing your colleagues at a
Well, there's that
conference.
too.
Yeah.
Or the undergrad, high school students who come visit
That's
the
right,
lab.
yes.
Okay.
All right, so TauSense, what is TauSense? TauSense is a function that's available on this specific version of the Stellaris 5. The white light laser is more than just a cool laser that's tunable, right? So the white light laser is actually pulsed, meaning the system knows when a pulse of light is generated,
Right.
and so we can leverage that pulse. That it pulses every 12.5 nanoseconds. So if we collect light in between that 12.5 nanoseconds, we can then measure how long it takes for
Yep.
a photon of light uh, to go from excitation to emission. So the excitation light will be excited by the laser.
Yeah.
The emission light will be collected by the detectors.
Yeah.
And the detectors will then measure light collection throughout that 12.5 nanoseconds.
So the point is, when you have two different things coming at different times, because they're different fluorophores, one's going to be seen at 3 nanoseconds and one's going to be seen at 8 nanoseconds.
Bingo, exactly. So we can actually start to measure like peaks. So just like you said, autofluorescence is super common, and autofluorescence has typically a short lifetime. The photons arrive very quickly after the pulse of light, and Alexa 488 arrives later, around 3 nanoseconds. And so if I have autofluorescence that fluoresces at 0.5 nanoseconds and Alexa 488 that emits at 3 nanoseconds, I can then start to separate those two signals based on lifetime. So we've been separating based on spectral for years and years and years.
Yep.
But we haven't been able to measure how long it takes for a photon to actually excite and then emit light. So
in some ways, what we really want as an ideal system to test that might be some of our live worms where we have gut autofluorescence and GFP.
That's right.
So maybe we can have Christina come in and do that towards the end of the next session.
Yeah, that'd be awesome. I mean, that's a perfect demonstration.
Okay.
It was beautiful in the
Yeah, I remember.
in the demo. But that is an opportunistic application. There are other applications where we can actually intentionally overlap fluorophores and spectrally, and then separate them with fluorescence lifetime. So, for instance, Alexa 546 and Alexa 555,
Right.
perfect overlap spectrally, but in terms of fluorescence lifetime, they are worlds apart. And so we're able to separate those really successfully. And so users that are interested in doing 6, 7, 8 labels on a single prep, that's how we're going to do it.
Yeah, so that's actually what we did in the demo, is we had 6 colors, but I only had a 568 and a 555, and we were able to distinguish those
Bingo,
two.
exactly. And so it's a really powerful tool. Again, that's really only available. It only became available to the mainstream with Stellaris 5. It has been available in research labs,
Right.
in physics labs, chemistry labs,
Sure.
people that do really custom stuff, but not in a mainstream microscope. So I brought you over to this poster so that we could talk about a couple of the different functions. We've got tau contrast, tau gating, and then tau separation. And these are the 3 functions that are going to be available in the software, and we'll take a look at these. So tau contrast is a powerful tool to be able to observe the different arrival times per pixel. So your typical image like this, this looks like some sort of a YFP. I guess it's Cellbrite 790. But you just get one. It's grayscale, pseudo-colored. But what you see here is a multicolored image, and if most users would look at this and say, oh, there are multiple labels on it. That's not true. In this case, instead of having multiple labels, we just have one label, but that label behaves differently based on the structure that it's bound to. So in this case, these, I'm not sure what they are, subcellular organelles, whatever they happen to be. Vesicles.
Once they're internalized, they're moving differently or behaving differently inside versus outside.
And what we're seeing here is a change in fluorescence lifetime because that label is bound to a different structure.
I see.
So the orange colors are kind of like late arriving photons, and these green colors are mid arriving photons, and then blue are the very early arriving photons. And so we can actually see a fluorescence lifetime difference.
That's
and so you can use this to do things like observe metabolic changes inside of cells, or as a precursor to go to somewhere else. You can use tau contrast to figure out, do I have a fluorescence lifetime difference that I can then leverage with one of these other tools. So with tau gate,
because for something like this, like we might not know that our protein behaves different. Like what I wanted to know when I saw that, is that really just a difference between We know that cells are growing. This is some aqueous environment outside the cell. This presumably brown is attached to the periphery, and then you're going through some cytoplasmic goo, right? So how much of this is the medium in which it's in
Yeah. Sure.
versus, like, is there a way of knowing that? Like,
Well,
is it really a different behavior of the fluorophore or the protein, or is it just a different medium that it's in?
Yeah, it's a different. It's typically not the medium, although it can change with the medium. It can change with pH.
Sure.
You know, so
So if it's put in a vacuole versus in
That's
just
right.
a extracellular.
and that's probably what we're seeing here is a
that
pH
makes
difference.
sense.
Yep.
Okay.
So
So for autophagy, this would be amazing. Things that are going to be degraded by inclusion into vesicles that change in pH over time as the protein's degraded, you
Yeah.
would really see that difference.
yeah, there's a very good chance, and
That's cool.
and so that's kind of why I bring this up, because a lot of people, like, they hear tau contrast. Well, how do I use it? That's one example. I don't know if it would work, but now you have a tool to be able to discover if it will. But cell
Yeah.
health, healthy cells versus dying cells. Like, if you're acquiring images and thinking that you're acquiring real data on a dying cell, like, that's not
Or
relevant.
maybe even, I mean, what might be fun for us to do, we might be able to do it today, or even generally, is to say, does our protein behave the same in a young versus an old worm? And you're
There you
saying
go.
that using this, we might be able to actually see that it's different simply because of the fluorescence imaging property.
It could be, and
That's
this is
right.
something
We don't
that
know
you can
until we do
explore.
it,
That's
right? That's
yeah.
fun.
Yeah, you can start to explore it. Okay.
So
and-
really what it is an exploratory new mechanism of potentially discovering new science in a way that we hadn't been able to before.
Bingo, exactly. And so, tau contrast is awesome, and hopefully you guys get a lot out of it. The next one is tau gating. So, as I had mentioned before, with my pulsed white light laser and my photon
Yep.
counting detectors, being able to measure the lifetime,
Yep.
I can actually set
Collection
time
window.
gates.
Yep.
I can set electronic time gates to only collect during a certain time window.
Yep.
So if I only wanted to collect this image between 2 nanoseconds and 3 nanoseconds, I can set up a time gate to only collect in that window and discard everything
Right,
else.
so then you're just going to see the green and not the yellow.
That's
Got it.
right. So, or in the case of your autofluorescent
Guts, yeah.
guts,
Not the gut, but my
the actual
protein
label,
of interest. Yep.
we only collect light during the real fluorescent
Yep.
event. And then the last one is tau separation, which in my opinion is probably one of the most powerful tools, where, you know, this is an example down here of an image that has multiple labels that overlap spectrally.
Yep.
But when we look at them with tau separation, we treat 2 channels as 2 channels, but instead of doing it spectrally, we do it with lifetime. We can actually see, you know, that
So
the
that means we
actin-
didn't have to set the collection time. It figures out the collection time.
That's right. Yeah, you just say there are 2 labels in here. 1, 2. Figure it out. there's
Nice.
literally a find button in the software that will find the 2 different labels, and you can see a picture of that here. You know, we can see that there are 2 peaks, and we'll see this in the software, where, you know, this first peak is the red channel, and this
Yeah.
next peak is the blue channel.
Yep.
So, and again, this is the tool that people will use to do
Yep.
like multiple fluorophores, like 5, 6, 7 labels on
Yeah.
a single prep.
Huh. Cool.
Okay, so in order to apply this in the software, it's not terribly hard, although it does require some setup knowledge.
Okay.
It's worth noting that TauSense only works with the white light laser, right? So
okay,
we
so-
can't do TauSense with the 405.
But
So
it can collect the 405 from the same sample?
That's right. We
Okay,
can
good.
collect the 405. We can use it, just
Right.
not with TauSense.
Sure.
So with TauSense, we've got to be using, you know, a green or a red
Sure.
label.
Far red. Yep.
That's right. So I'm going to do this. We'll open this up a little bit. So in the detector, when I click on this detector, HIDS2, you know, there are the functions that we saw in the panel box, like the gain and, you know, the label.
Sorry, do these appear when you click on that?
That's right. Yep.
Okay, so can you do it down here so I can see? And now click, but this one stayed up.
That's right, yeah. So this one is specific to the setting. So if I click this laser line, you can see I now get laser information. But if I click this detector,
Oh, I get detector.
I get detector information.
And what if I click the white light button?
I don't think anything happens.
Okay, just checking.
You get a bubble window that says
Okay.
WLL.
Perfect.
Okay. All right, so in order to activate this, it's pretty straightforward. Tau contrast is just a toggle.
Yep.
So we just turn it on.
Oh,
All right, and we're going to get a tau contrast image and an intensity image. And so let's go ahead and click live.
wait, what's an intensity image?
It's what we've been looking at this whole time.
Okay, so just so you know, sorry, let's go back to like 1 or 2 line average.
Yeah, there we go. Okay, and now we'll go live. And double click to get out. So this is our tau contrast image, and there's, here, let's just do a quick,
Oh. But how come there's nothing in the green channel by itself up here? Oh, okay.
so one thing that happened kind of behind the scenes is this detector switched to photon counting mode. Because remember I was telling you like pulse laser, photon counting detectors, it switched modes. And so now we have our intensity image and our tau contrast image. This is going to be controlled with a color gradient.
That's this.
This right here. So let's go ahead and bring this down. Let's go ahead and bring this up a little bit. And we can start to see a little, there's a little bit of a difference there. Not a lot. We're getting some red pixels and some blue pixels, not a ton.
Actually, you know, okay, I'm sort of curious what would happen with the one with the foci. So if we did it in this channel instead, because that,
There's there's something possibly unique to that one, or
no, I just was wondering whether the other foci are actually background and different.
Okay, well, we can do that. So
And they're probably
let's go
not
ahead and
real.
stop.
They're probably still antibody background. So, well, you could keep it on here because you've adjusted it.
Sure. Okay. Let's double click, go back out.
And it worked the same way with the gain and everything. That's what you were playing with to get the signal intensity what you wanted.
So, yeah. So
Sorry.
this is a great point. When we go to tau contrast, you'll notice
That's brighter.
the gain is disabled.
But in this, it's not.
Well, when we're in photon counting mode,
Oh, it's disabled.
we're counting photons
So how did you get it brighter?
by adjusting the histogram.
Okay.
So no gain in photon counting mode. But now this detector right now, HIDS3, is in analog mode, and when I select this one, look, I get my gain back. Okay, but now when I switch on to tau contrast,
this is disabled. Got it.
Yep, we're in photon
Okay.
counting mode.
Intensity counting. Got it.
And so now let's just capture an image again.
So why did you? Oh, you're capturing an image.
Yeah, just instead of
Oh, so now this, then this is to this, and this is to this.
yeah. So this is where it gets a little. It can be
Annoying.
sometimes confusing, which is why there are these handy dandy little labels on there. It tells you
Yes.
what's what. So now let's increase this a bit, and let's do this and adjust that. Let's bring that full screen. So we've got, your foci are very early arrivers, and this background looks like it's kind of mid.
Yeah, well, that's what I was hoping to get rid of is that background.
Is the
stuff.
background, yeah. So we might have some success here. So let's turn off tau contrast. All right? And let's go.
We definitely want to turn it off on this one because we don't need it. We're just going to do it on this channel.
Okay, you want to do it over here? No problem.
Sorry.
You can do that. No, you're
Right,
fine.
because this is the foci.
Yep.
Okay.
All right. So now we're going to do this thing called tau separation.
Okay. This is the one. Hold on.
That's the last one on the list.
Okay, that's the one where it calculates it for us.
This is the one where we're actually gonna see a graph of the
Output. Oh,
that's
so what it's doing is it's giving us a graph of the times, and then we get to gate on those times. Oh, I get it.
Great. So let's do that.
Okay, so you did it by doing image.
So now I'm just live. That's right.
Oh, okay.
And I activated this tau separation.
Okay.
And now I'm going to click this plus button, and this is going to give us.
Ooh, I'm so excited.
Here, and remember that easy button. Just click find.
Yep. Well, that was
There we
obvious what
go.
the two are. Okay, so
Yep.
now you can stop, right? Does it keep
Yep.
it if you stop?
It kind of does.
Okay.
Yeah, that's fine. All right, so let's get out of here, and let's look at.
That's this one.
So this is your tau contrast. This is your 1 nanosecond region.
Oh, I see. Oh, it gave the two separations already. I see.
That's right. And let's just kind of hide these other ones for now.
Right.
So this is your. So it looks like that background does fall into the range. We might be able to do a little tweaking to improve it, but
So wait. Hold on. This is separation.
this is contrast. This is separation with 1 nanosecond. And this is the 3 nanosecond
So
window.
get rid of this one.
Okay.
Because what we want to know is really, so now zoom in on this. Right, so it looks like really, there's not very many spots that are one and not the other here.
That's right. Yeah, they're pretty similar.
Yeah.
It may just be non-specific labeling.
Yeah, well, that's what I expected it was. I was just hoping that maybe the
Maybe,
non-specific
yeah.
labeling could go away, right? I mean, it
So-
might be real non-specific. I mean, it maybe, so remember, what we are looking at is foci that correspond to proteins accumulating at a given spot in the cell. The rest of the background may be truly real signal,
Got
which
it.
is the wild type distribution of the protein in the cell. I was just wondering whether it by chance was different associated to the DNA or not, in which case
Got
we
it.
could have seen it.
There is is this an Alexa floor?
Yes.
So most Alexa floors do have an autofluorescent region
Ah.
right here. And so if I look at this
Uh-huh.
display range, I auto scale to 12.
12.
This one is at 23.
Uh-huh.
So there is a decent amount of contribution from that Alexa autofluorescence.
I see.
So you can remove it and get a cleaner signal.
I see. That's nice.
But in this case, it's not quite as dramatic
Yeah.
as like
No,
a
but
live
still,
signal.
that's nice to get a.
Yeah.
I mean, anything that cleans up our signal, particularly for things that are sort of sloppy, is actually
Yeah.
really good.
For sure. And we haven't gotten into it because it requires a lot of clicking and thinking, but you can combine these techniques with lightning. So if you wanted to, for
Sure.
instance, like have a really nice
Well, we
super
would.
resolution image where you remove the background, you can do that. If you
Yeah.
want to apply it in Navigator, you can do that too.
I see.
So,
But this, the separation, so you're saying it can be done afterwards? I thought it had to be done while
you
it
would
was-
have to set this up
During
first
collection.
and then do your lightning
Yeah.
or then go to
Yes.
Navigator.
Okay.
Yep. So
What's this one? So maybe.
well, good question. Hang on here. Let's go back to intensity.
So intensity is our normal. So what happens if it had none? Why would it have none on it?
If you were just showing tau contrast,
Oh.
but if we turn off tau contrast,
it automatically goes to intensity.
That's right.
Great.
So the next one is tau gating. I'll touch on this in a minute. The tau gating. So in the scenario, like based on the tau separation curve, we learned that your real signal is 1 nanosecond to 3
Right.
nanoseconds, or effectively around 3 nanoseconds.
Right.
So with tau gating, I can kind of just skip that and go from 2
I see.
to 4, and I'm only going to collect light in this
Okay.
time window.
Okay.
And so now I do that. And the reason that I would want to do that is if I have a huge Z stack, that sort of thing, or I just don't need that other channel.
Oh, where'd it go?
I just wasn't displaying it.
Oh.
And so this is your cleaned up signal.
Timed signal.
Yeah. Not a lot of, so in this case, what we might need to do.
Yeah, it actually made my image dimmer, right? Because the things
Yeah,
that
that's
I wanted.
okay. So what we do here when we're in photon counting mode, there's usually not a lot of photons. So what we're going to do is we're actually going to do a line accumulation to
Oh.
strengthen the signal. Because
Okay.
we don't have gain,
Yep.
but we can either increase laser power or do a line accumulation. So line accumulation is a great way to improve your image without hitting it with a lot of laser power.
Ooh. And it has to do it for all. Oh, if I'd been in this, we could have done it for just this. 'Cause
Yeah,
these are
and it
fine.
looks like
Yeah.
I saturated the
Yeah.
405.
Yeah, it's okay. What did you do? What
I
did
just
you
turned down the laser power on the 405, so by mousing over the 405, I can use the mouse wheel to like lower the laser
Oh,
power.
you're tricky.
I am so fast. You've got to.
I saw that you did something. I just didn't know what you did. It's like, what did he do?
You really got to pay attention when I'm clicking. All right, so we'll capture one more image to see if I get that UV. Yeah, now it's looking better. It's
Yeah. Nice. Yeah, much better.
And so here we
Yeah.
have the foci with not a lot of background out there.
Yeah.
I mean, there's again non-specific labeling. It
But
is what it is.
again, I don't think it may not be truly non-specific. I mean, it may be the free
Yeah.
protein. I don't think it's really,
Sure.
it looks non-specific. Here, I think it's non-specific.
Got it.
Um,
Yeah. It is what it is.
it is what it is.
So okay,
And how do I get rid of the histogram? Oh, I just click off.
there you go.
Okay.
Yep.
Okay, so let me ask a couple more questions.
Yep.
This one right here, that's just, so it's always going to be all 4 channels versus 1 channel. I'm clicking between the channels that are being shown in the 4 panel, or I can double click it and it just goes to 1.
Yeah.
Or click back to whatever one's open. Okay, that's good. And what was this one right here?
That's your overlay.
Oh, whether I want the overlay or not.
Mhm.
I expected it to be red. It should be red.
Oh,
You should
that
tell them
is
it should be-
interesting.
You should tell them it should be red.
That is a great. Yeah, that's a great point.
That one, because yeah. And what's this one?
Uh,
Oh, if I don't want the words, if I want to image
Yeah.
quality. Oh,
It shows these labels.
yes. So if I wanted this
If you find
for
those labels
publication,
distracting.
if I wanted to do this, and now I wanted to put a scale bar on it, I click on my little scale bar, I put it on. Oh, it's crooked. How do I get rid of it?
No, you're okay.
No, what if I don't like it because it's not straight?
Well, then you can right click
Uh-huh.
and come
Property.
to properties.
Oh, and let's make it 5 microns. 0. Oh, I love it.
5.
Nice. Can I change the color? Go back.
I believe so. Properties.
Color. White. Gray. Yeah, that's good. Much better. And I can move it around just by clicking and dragging?
Yes.
Nice. And I can I saw that I could take the words off. But I think a lot of people will want that. If I now zoom in, does it keep the scale bar there? No. I have to move it to a place where I can see it. Just so you know, that's what I do. But people could, it gives us a ballpark. How big is our nuclei? Right?
All right. That is
Sorry, I
actually a
just-
good point. No.
And does it save? So when I do that, does it put the scale bar on all my images or just the one I'm looking
Good
at?
question. All right, so we're gonna phase in. We're gonna phasing out of tau.
Oh, are
sense,
we
and
done?
we're-
I'm sorry.
No, it's okay. And let's phase into data export because this is important.
Okay. So wait,
So-
are we done with have I learned everything I need to learn about tau
Effectively,
sense?
yeah. I mean,
now.
without getting.
Until we have a good sample where we
Bingo.
can really separate. Okay, so hopefully later today we can do that.
Yeah.
After Miguel and Christina are done.
Okay.
Okay.
So, data export. So here in open projects, first of all, you can create as many projects as you want to organize your data, right?
Great.
So data organization, important. Create lots of projects specific to your imaging. So in this case, I want to export this image because I think,
No, this is the one we just did. Which one do you want to export?
yeah, sure, this one. All right.
So hold on. So just to be right, so this is just like any other PC where we click, change the name. This is going to be ATG7 RAD 51. Okay. And then image 6. Okay.
Yeah.
And then we have to, I presume we have to click the save bar to save all of these.
Yeah, click the
Okay.
floppy disk. Like I said, we're
It's
not
different.
done with the floppy disks yet. I don't know why they do that.
Okay.
Okay, so getting your images out of the software.
Forgot meaning.
is just a matter of right-clicking your data set here,
Okay.
the image that you want. First, let me back up and say that exporting an image should probably be reserved for, publications, posters, presentations, that sort of thing. Like, keep your data
All together.
together.
Yeah.
That's right. When you need to get it out for a presentation, you get it out for a presentation.
Yeah.
So this is not something that you're going to be doing every day.
Sure.
But when you do export, right-click the image, export, and you have lots of choices. You can do a movie, you can do an image. In this case, we're just doing an image. We want to export it as a TIFF. We want to send it somewhere that's relevant. Let's make a new one here.
JLY.
JLY. And we click OK. And so we have
And
the
we're supposed to save all our data on the E drive.
E drive. Yes.
Okay. Oh, sorry. Can you go back to this so that we can talk about the different places? So there's,
You could save it on the desktop, and that would be bad.
okay, no saving on the desktop. Okay. So then there's, what's on the C drive? Why
The
can't we
C-
save it on the C drive?
Yeah, I mean, the C drive is fine to a point, I mean, but
But it
there's
fills up and then it interferes with the running of the machine.
bingo, and there is invariably one person that has 100 gigs of data on the
Right.
C drive,
Well,
and
that's
it's like,
me, by the way.
yeah.
Just so you know.
And then you have to go find that person and ask if you can
Right.
move it. And,
Yep.
anyway, so if you just save it to the E drive,
And how much space do we have on the E drive?
6 terabytes.
Okay.
So loads of space.
Okay.
But it is just a regular computer. If you run out of storage space, you can add another hard drive. You can
Okay. But it does have a nice little place for our thumb drives to
That's
go
right.
in. So we should,
exactly portable
Um,
hard drives are a great thing.
okay.
Yes.
And we're going to be having right next to us another system to do all the visualization. So we,
Perfect.
but there wouldn't be a way to connect the two computers, would there, to transfer?
You could.
That might be
you
a good
could.
idea.
Yeah.
We can talk about that.
Yeah.
Okay.
All right. There's also the temp drive, which has 2 gigs, but it's a temp drive. The temp drive is reserved for like the data that we're saving here.
I see. Right.
So
So it's
it's-
automatically saving it until I save it.
That's right. Exactly.
Okay.
That drive is reserved for using
No.
the software.
Okay. So basically, when somebody comes for training, the important thing is that each of the people who are trained will get a folder on the E drive
Bingo.
that they will use, and
Yep.
probably we'll do it by lab, so that every lab has a folder, and then there's sub-users within the labs.
Yep. I think
Perfect.
that's a great way to do it.
Awesome.
All right. So we're going to export this one to yours, JLY.
Okay.
It's going to be a TIFF.
Yep.
I want to export all 3 images.
Yep.
And I have a choice here of the raw image or the scaled viewer image. So a scaled viewer image will export it the way that you see it here.
Ah.
A raw image will export it like this. Whoops, hang on. Oh, I can't click it. But basically,
By the way it was
won't be
taken.
scaled.
Yeah.
That's right. Yep. So
Okay.
I want the
Good.
scaled viewer image
Okay.
personally.
And does that also zoom things in? If I was zooming in. Remember, I was zooming in before. Kind of screenshot zoom.
It will not honor your zoom. There is a way to do that. It's not ideal.
Tell me that's going to be in the next build.
I wish I could. I wish I could.
Okay. I'll just cry.
Yeah. So we
Because
want
otherwise we have to scale it in
Photoshop.
Photoshop.
Yeah. Sadly.
Or can we take screenshots?
Yeah, you can take screenshots. I can show you how to do it.
Okay.
All right. Export overlay because I want 1, 2, 3 and the overlay.
Yes.
All right. Great.
Can this default?
What do you mean?
Can this be the default?
Yeah, I think it actually was, but I was clicking around.
Oh, okay.
Yeah.
Let's check
Yeah.
it out. Okay.
Yeah. All right. And then we already have our scale bar on there, so no worries.
Yep.
And then we click save.
It doesn't say you don't have to click to keep it on there?
No, right now it's not. There used to be a button to save annotations. Let's see what happens.
Okay.
All right, hang on.
E drive. Judy.
I didn't save it.
It saved it as 4 different files.
Yeah, so you have an overlay,
Oh.
blue, green, red.
Oh, okay.
But it didn't save your annotation, and I can't remember.
Maybe Tiger is. Export image. I'll bet you click on scale bar. I'll bet you it's that.
Well, so this is a different kind of scale bar.
Oh. Okay, hold on, cancel.
Not my favorite.
Okay, so you're gonna work on figuring that out.
How
it's
to
very
export
important.
the annotation.
Absolutely critically
Okay.
important.
All right.
Show me how to do a screensaver though. Screenshot.
Yeah.
So let's say I wanted to.
Yeah, just go ahead and right-click that image.
Let's say that's my publication image, which it's not, but it's close.
Okay.
Snapshot?
Snapshot all.
Oh, look at that. And then I export that.
Yep.
Oh, look at that. Why is it showing that right there?
That's a great question. Because it really likes to mess with you. I don't know. That is so weird.
Bug in the system. I find them all.
Yes, you did find a bug. You found it. Oh my gosh.
I told you you should just have me. I should be paid to debug Confocal software.
Okay. I've
You can
never
report
seen
that
that
one.
before. Yeah. All right. Okay. Well,
Okay, so let's go back to, I just need to know a couple more. So that's really great. And can you explain just a little more? I want to make sure when we're doing this type, so I now see how we can put this on. We'll figure out how to take the image with it. What are the arrows and the checks and the this?
Yeah, so you used.
Maybe it was that we didn't check it on. What's the check? Yeah, you see you took it off.
Well, annotations, I wonder if this is why. So if I do this here and I right click, properties 5.
You can keep it this color for it.
Look at
It's
that,
fine.
I got a 0 already.
I know, you're
Man,
so good.
I am good. All right, so now if I now if I go and I export
Oh, because you did it as an annotation instead.
annotations.
And I didn't have it as annotations. I just had the scale bar
Yeah,
checked.
that's the difference.
Okay. Oh,
There
there
it
you
is.
go. Nice. Still not zoomed in. Oh, but right, and we already did it as a screensaver.
But now
Let's see if you do it as a screensaver now that it's an annotation and not just a scale bar.
Yeah, that's right. No more bug.
Still there, but I mean, there's still a bug. It's just not in where you thought it was. So nice. Okay. That's
No,
good.
I just fixed your bug, Judy.
No, you got
fixed
me a
it.
go round. It did disappear.
Okay, all right.
Just so you know. Okay. So thank you for looking at our videos on the training on the Stellaris system. Before we move on, I want to give you some troubleshooting tips. When people come to me and say they can't see their samples, most often the reason is because they've actually put their slides onto the confocal incorrectly. Usually it's because they've put the cover slip facing up instead of facing down. So before you come and find me or a member of my lab to help you troubleshoot on the confocal, please look to see if you've actually put your slide on correctly. The second problem that we often find is actually that people haven't pushed the button to go to the confocal on the software. Hopefully that's no longer a problem on this new Leica system, but just in case, please make sure that you've pressed CS on the panel in front of the microscope as you go use the confocal system. We think that should be some of the major problems that you will confront. I do also want to address, however, sample prep. So what's really beautiful about this system is it's exquisitely sensitive. And that means it's sensitive to the different types of cover slip medium that we're using. So in my lab, we tend to use the Prolong series of mounting medias, such as Prolong Gold or Prolong Diamond. But some of you may be using VectiShield or glycerol-based mounting medias. You need to make sure you know what mounting media you have used for your sample, because that will really influence how well the image comes out. The other thing that's critically important is that you actually have to make sure that the cover slip has cured overnight, or if you've used nail polish, that it's been dried for several hours before you put it onto the confocal itself. And that's to ensure that the mounting media doesn't get onto the very valuable objectives that we have on the system. I think that covers everything for now. This is the beginning of your training. And what that means is that after you've seen these videos, you're going to contact me to have an in-person training to make sure that what you've learned through these videos, you can now apply in person.